Hi everyone, today is June 24th, 2018, and today we will continue to talk about the PMP problem, and this will be the fourth video to talk about this project. And from last week, we were talking about to generate a 3SAT graph by using two literals combination to represent a single node. But this time we will do a little updates and to use the OR logic instead of AND logic. But we will still use two literals together to represent a single nodes. But we think that using the OR will be more straightforward and easy to follow. So, and besides that, we will also use a library called mxgraph, and it is a fully client-side JavaScript diagramming library that use SVG and also the HTML for rendering. So basically it's a JavaScript library but also have the Java version. So we imported the library from GitHub into this project so we can use that in our program. So let's go ahead and take a look at the code we have today. So in the main method of this main class, and we have so we have a hard-coded string to parse to the 3SAT parser as the video talked about a few weeks ago, and this will be able to help us to parse this string to the variables, literals, and class, and then we can use this to get a formula, and then we put this formula into this graph 3SAT methods, and this class, and to generate a new instance of this class. And let's take a look at this graph 3SAT and what we will get from this this class. So let's dive into and see. Yes, so we have a formula, 3SAT formula as an input, and we will get the number of literals, and we will get number of nodes, and we will also get a adjacency list, and this will be used in the Tarjan algorithm to find out the strongly complete components, and then we will also get all the literals and also its negations, and we will get few types, type 1 to 5 edges, or that is edges connected. So we add edges as the index will be same as last time when we use a AND logic, but this time we will represent the OR, but the index will be the same. So the L1 times NL plus time L2 plus NL times NL will be represent L1 or L2, and this one will represent L3 or L3. So basically that's the same. So yeah, as we see from this method, we will get the edges added, and this will covers all the possibilities and between the inside this formula. Sorry. So let's go back to the main class, and in the main methods here, let's take a look at what we will get, and for refresh on this new instance. Okay, so let's go one step further, and so we will take a look at we get six types of edges, 5 types of edges. So basically they will get all the situations covered here. So let's go back to the code. So after this, we have a graph available. So this is with all the edges and nodes being generated. And then we will use a draw.graph method and to use this to draw a mxgraph. So let's dive into this method and take a look at what's going on. So in this method, the return type is a mxgraph. So basically, we will use we will new instance of mxgraph as a graph, and we will call the getDefaultParent from this class. And the most important thing here is we will use the insert vertex and insert edge methods in this class to generate the nodes and also the edges in the graph, and then to print them out. And for the vertex, we need to know the index to label. So this is a method that we talked about last time. That is to reversely to get back the label by the index. So basically, we'll use the divide and module, and to get the two, because we know every index was represented by two literals, so we will get two literals by the single index from this method. So let's go back here. So this index to label will give us two literals, and we can know these two literals represent the single nodes, and we will insert a vertex based on this information, and later we will get all the edges that added and based on the adjacency list of the index. So so let's take a look at this how this what we will get from this result. So let's just run. Okay, sorry. So we just run this whole program. So then we will get a graph here. So this is a mxgraph library that generated based on our nodes, vertex, and also the edges we have from the 3SAT graph. So this is the first method we will first main class we will talk about today. So let's go ahead and take a look at we have a second main method here. So let's comment this out and to make this valid. And for these main methods, and basically it's very similar, and we will continue some further works based on the previous main methods. And in these main methods, we also have a hard-coded string as an input of 3SAT formula, and then we will use a parser to get the same formula, 3SAT formula, and put them into a graph 3SAT new instance of class. And so we have several printouts about the graph what is a graph, and we also can call from the graph 3SAT class, and there is a method called the get strongly connected component method, and we will also be able to reversely get back the literals of the strongly connected components by this index, because from this method we only get the index from the methods. So if we need to get the string literals, we will use this strongly connected to strongly connected literals method. So this is what we talked about, I think, in last few videos. But this time, we will continue, and to continue now, we will get a graph of 3 SAT, but today we will continue and to get a 2 SAT formula actually based on the 3 SAT graph we have. So let's dive into and take a look at what's inside. So for the get formula 2 SAT, basically we have a 3 SAT graph right now. We will based on for every positive literals. Here we plus 2 every time because we know the start from 0, 1, 0, 2, 4, and they will be the positive literals. And so we based on these positive literals, and we can ignore, we can downgrade, or we can simplify the 3 SAT into a 2 SAT formula. And because we exclude the positive one. So for every positive literals, we will find out the common nodes that they imply both this index represent the if we call this node as I or X, let's call it X, and it will symbolize a X or X. And if we find out these nodes X or X, and the negation X or X, and if they are symbolized, if they are common nodes that imply by both these two nodes, that means we will find out them and to add them into the edge of this 2 SAT formula. So if we find they match each other, we will put them into the string, and based on this divide and module function, that is we just talk about to reversely get back the literals by the index. So here we will find out the in literal combination that the nodes represented, and we will return a string as 2 SAT formula. So basically this method will return us a 2 SAT formula based on the 3 SAT graph. So let's go back to the main class. So here we can see we call this get formula 2 SAT from the same graph 3 SAT class, and then we will print out the derived formula. Remember, right now we only get a string of the formula, so the same thing will happen on the 2 SAT formula. We will parse it to the actual string or actual formula that our program is able to recognize. And so we will use a parser to get the variables, literals, and clauses available from the string. So then we will get a 2 SAT formula here. So based on this formula, and we will put them in a Tarjan solver. Remember, this Tarjan solver will help us to get to find out the strongly connected components, and then based on those, we will try to make them each true, and then we will be able to find out whether we can find the assignments to make the whole formula true. So here we knew a Tarjan solver, and then we call the solve function solve method. So let's take a look at the solve method. So the sort method will firstly get all the variables and all the literals, and so we will get we now have the two SAT formula, and we will get the strongly connected components from this formula. And firstly, we will set all the variables of value, var value, to -1, and then we will set them to 1 or 0 respectively. But remember, our graph is a symmetric schematic graph. So that means if we assign x, we've already assigned a class, the value of a class, and the negation will be also assigned at the same time. So we will check for every strongly connected component if the first value, variable value, if it is not -1, that means we've already assigned this. So we will ignore the rest of work, and we will continue to check the next one. So, and if we find out that it's still -1, sorry, that means we haven't assigned the value to this class already. So we will check if for the integers in the closet, and we will get the literals from the index, and we will check if it is positive or it is not positive. That means we will make a positive literal true, or we will make a negation literal true. And if we are able to do that, we will set them to 1 or 0. And if not able to do that, we will return the null. Instead, we will return the vars. So let's go back to the main method. So if we are able to get the vars, and we will print out here, vars are vars, and so we will also record the start time and the end time. So we will be able to calculate the time that we are running this program. And finally, we will check if the vars, if it is null, or if there are some values inside, and we will determine the formula is satisfiable or it is not satisfiable. If it is satisfiable, we will read through the vars string, and then we'll get the value for each one that could be assigned, and then make the formula true. So we will print out each one and get the var name and also get the var value. So we will get the value to make them true. So basically this is the idea. So let's run this program again. And this time we should be able to see the things we talk about here. From the result, we are able to derive the 2 SAT formula from the 3 SAT graph, and we will also be able to put a Tarjan solver and to check whether they're satisfiable. And finally, we are able to find out the var string. So we are able to read the variable's value from the var string here. So that means this formula is satisfiable and is able to find out assignments to make the formula true. So basically, this will be the overall review of the program we have today. Basically, we use have a summarize. We will use OR logic instead of AND logic, but we'll still use 2 literals to represent a node in the 3 SAT graph. So that's the difference from last time. Besides that, we will use mxgraph. That is basically a JavaScript library, and that's a diagramming library that uses SVG and HTML that for rendering. So we are able to use also a Java version, that to draw out our graph, and so we are able to see the three SAT graph from the program. So and then we'll introduce another main class, and that is to able to help us to get the get the two SAT formula from the three SAT graph, and then we will use the two SAT graph and to put them into a Tarjan solver, and the Tarjan solver will be able to help us to find whether the formula is satisfiable by checking by presetting all the variables value to -1, and then we will set them to 1 or 0, and in order to make every strongly connected component to be true. If we are not able to find that, we will return null as of to the var. So by checking the var, we will be able to find out whether this formula is satisfiable. So overall is contents of this week's code and projects. So hopefully this will be helpful, and yeah, so this is all for today, and thank you for your time, and until next time, happy coding. Thank you.